So now we are going to discuss about complex compounds in that crystal field theory. So according to this theory, so the strong electrostatic attraction are observed between metal and ligands. So that is electrostatic attraction is nothing but ionic bonds. So that to be a strong unipositive or negative electrostatic attractions. So that is ionic bonds. Next, in complex compounds, the metal is surrounded with ligands. So some number of ligands. Next, the d orbital is classified into two types. So d orbital contains how many? 5 suborbitals are there. So what are that? Dx square minus y square, dz square. Next, dxy, dyz, dxz. Suppose if you see the orientation of dx square minus y square, this is dx square minus y square. Next, dz square, x, y, it is z you can take. This is a dz square. See, these two are present upon the axis. These are called as Eg orbitals. So doubly generated orbitals. Next, x, y. Between x and y, that is a dxy. In between y and z, double dyz. In between x and z, dxz. So these are in between the axis. So these are three members. So triply generated orbitals. Next, fourth point. See, you take metal. So the ligands are coming close to the metal. So then what happens? D block, D orbital is present in ground state. If ligands are coming means it is excited. You are getting a degenerated level. Next, again these ligands are very close to the metal. So then it is splitting into T2G orbitals and EG orbitals. It is the degenerated energy level. Say depending upon the ligand coming area, so T2G or EG, they are splitting also. This is next. This theory perfectly explains the strength of ligands. So strength of ligands is perfectly explained based on electrochemical series. So electrochemical series according to that ligands. So iodine, bromine, SCN minus chlorine, NO3, F minus, OH minus. So this is weak field ligands. Next, further continuation. Water is very close to EDTA, is ammonia. Next, pyridine. Next, ethylene diamine, bipyridine, orthophenanthrene. Next, NO2 minus. Here NO3, here NO2. Next, cyanide minus. Next, carbon monoxide. It is very powerful. So these are strong field ligands. The great success of this theory is the explanation of the strength of ligands only. So in your entrance, which of the following is a correct order? Otherwise, which of the following ligand has more strength? Which of the following is less strength? Also, they can ask questions. Next, see, in the presence of a strong field and weak field ligand, what happens? See, 5 ground state. Ground state degenerated, so it is excited, so degenerated. So degenerated level. If a strong field ligand is coming, strong field ligand is means the splitting is more. This is a strong field ligand. In the presence of strong field ligand, the energy gap between T2G and EG is increases. Next, in the presence of weak field ligand, so T2G is this and EG. So the energy gap is less in the presence of weak field ligand. So in the presence of strong field ligands, a large gap is observed. Next, seventh one. It is perfectly explains about color properties. So this is very important. See how the color is observed. Suppose the light is falling on the object, that will be absorbed some light and ejected something, that is fell on retina, our eye. So then only the color is observed. But here, see, ground stated D orbital is excited and occupying degenerated level. Next, in the presence of ligand, what happens? It is splitted into T2G and EG. Suppose in T2G, one electron is there. So if light is falling on the electron, H nu light, so the electron is jumping and occupying high energy. So energy increases. Energy increases means what happens to stability? So that is decreases. So here energy is increases. So the electron is occupying high energy. High energy means low stability. So that's why again the electron is coming down to its original position. In the meanwhile, whatever the absorbed energy is coming out as radiation is nothing but color. So in one word you can tell means T2G means it is d orbital only. EG means this is also d orbital only. So the color is responsible for D to D electron transition. So the electron jumping from d orbital to d orbital is the responsible for the color property. Next, the stability. The stability of complexes. The stability of complexes is explained through CFSE values. So that is crystal field. crystal field stabilizing energy. So what it is, we can clearly discuss about the examples of the compounds. So here we will take that important points. The splitting of d orbitals in octahedral complex. See, suppose octahedral hybridization is what? sp3d2, otherwise d2sp3. So this is what? Outer orbital complex. This is inner orbital complex according to VBT. See, now if you take octahedral structure means, so this is two-dimensional structure. Suppose you want to know the three-dimensional structure, means the cubical structure is the better to explain. So metal is in between that, here two ligands on the face center. So below and above face center. So front and back face center. See, the ligands are approach the metal on the x-axis. The ligands are approaching on the metal y-axis. The ligands approaching the metal on z-axis. So who are present on the z-axis? So means, so the d orbitals which are present on the axis. So that is what? Dx square minus y square and dz square feels more repulsions, means energy increases. So automatically this is what? Eg orbitals. Eg energy is increases means T2g orbital energy is decreases. So now we write the graphical representation. See, both we can write here. Ground state. So degenerate. So strong field also at a time you can write. So T2G and EG. This is a strong field ligand. Next, degenerated level, weak field you write. So in the presence of weak field ligand, so this is a T2G and this is EG. Here, the distance between this. Here, below your maximum electrons are 6. This total you can take delta 0, octahedral splitting energy. So this is this energy value and this energy value from the degenerated level. Here 6 are there. So you can write as 0.6 plus 0.6 delta 0 value. Next it is a down. So minus maximum 4 electrons. So 0.4 delta 0 value. So here 6 electrons maximum, here 4 electrons. How to balance means this is this area multiplied with 6, this area is multiplied with 4. So you can get. So here also same thing. So this area you are getting minus 0.4. Minus 0.4 delta 0. This area plus 0.6 delta 0 value. So why we are taken means you can identify CFSE value also. CFSE value means that is number of electrons in a T2G into T2G value what? Minus 0.4 delta 0 plus. So number of electrons in EG into plus 0.6 delta 0. See here, D electronic configuration. D electronic configuration. Next. So weak field ligand. So in the presence of weak field ligand, electronic configuration and CFSE value. Next, strong field ligand, electronic configuration, next CFSE values. So these are important your NEET and JEE mains also. See, suppose I am taking D1. D1 electronic configuration means where you can write one electron is here, one electron is here. So you can write T2G1 EG0. So what is the CFSE? So T2G value 1 into this one minus 0.4 delta 0. Strong field also T2G1 EG0 minus 0.4 delta 0. Next D2, second electron you write here, second electron you write here. So that is what? T2G2 EG0. So 2 into minus 0.4 minus 0.8 delta 0. Here also same T2G2 EG0 minus 0.8 delta 0. Next D3. So third electron. Here also same. Here also same. So T2G3 EG0. So 3 into minus 0.4. So that is a minus 1.2 delta 0. T2G3 EG0 minus 1.2 delta 0. Next, D4. Fourth electron. See, energy gap is small. So that's why electron is not, half filled is more stable. So that's why fourth electron is going above. So you write as T2G3 EG1. So that's why 3 into minus 4 minus 1.2 minus 1.2. One electron is here plus 1.6. So that is what? Minus 0.6 delta 0. So here the gap is very large. So fourth electron is not going above. So fourth electron is paired with this only. So that's why in the presence of a strong field electron, so the electrons are paired. So that is the success of CFT. So then what happens here? T2G4 EG0. So 4 into 4 minus 1.6 delta 0. D5. So fifth electron is going above. So T2G3 EG2 perfectly balanced. So 0 delta O. Fifth electron is paired with second. So T2G5 EG0. So that is minus 2.0 delta 0. Next D6, sixth electron combining with first. So you are getting T2G4 EG2. So then what happens here? 4 fours minus 1.6 plus 1.2. So that is what? Minus 0.4. So minus 0.4 delta 0. here sixth electron combining with this. So you are getting T2G6 Eg0. So 6 into zero point 0.4 minus 2.4 delta 0. Next. So D7. 7 means seventh electron combining with this. So T2G5 Eg2. So 5 fours 2 minus 12 means what? Minus zero point 0.8 delta 0. So seventh electron is going above. So T2G6 Eg1. So here minus 2.4 minus 2.4 plus 0.6 minus 1.8 delta 0. Next D8. So 8th electron combining here. So T2G6 Eg2. So that means minus 2.4 2 plus 1.2, that is minus 1.2 delta 0. Here 8th electron is coming here, so you are getting same T2G6 6 electrons, Eg2 electrons, so that is minus 1.2 delta 0. D9. So T2G6 here 9th electron, so Eg3 minus 2.4, so minus 2.4 here plus 1.8, that means what? 6 minus zero point 0.6 delta 0. So here 8th electron 9th electron combining with 7, so here also same T2G6 Eg3. So value minus 0.6 delta 0. So last one. D10. D10 means 10th electron combining with 5. So you are getting T2G6 Eg4. So 0 delta 0. Next here also 10th one combining with 8th one. So T2G6 Eg4. So 0 delta 0. Everything is cancelled. Okay, this is about octahedral complex splitting. Next, d-orbital splitting. So d-orbital splitting in tetrahedral complex. So tetrahedral complex, so hybridization is sp3. sp3 structure tetrahedral. See, suppose in two-dimensional structure, in what way it is? So tetrahedral, this is a two-dimensional structure. Suppose you want to 3D means you can take a cubical structure. So in cubical structure, metal is in middle. So two ligands are like this. Next, another two ligands. So here, how these are coming? Opposite you can take. Here, L is there. Here. So the ligands are approaching the metal in between the axis, x-axis, y-axis. So who are present in between the axis? T2G. T2G feels more repulsion. More repulsion means their energy also increases. So automatically T2G energy increases means EG energy is decreases. So D orbital ground state, D orbital is excited, degenerated. So now who is going above? T2G is going above side. Next who is coming down? EG is coming down. So this is the energy order. See, next the distance between this energy you can take as delta T. So that is the energy splitting of tetrahedral complex. So O means octahedral. So the important point is here. So delta O is greater than delta T. So that to be how much it is delta O equal to 9 by 4 of delta T. So that one formula. Say they will provide delta 0 value and they will ask about delta T. So you find out delta 0, you take this side 4 by 9 you multiply. So you will get delta T value. But anyhow delta O octahedral is greater than delta T. Next, d orbital splitting in square planar complex. So square planar means hybridization is DSP2. Square planar. Suppose two-dimensional structure is so just simply like this. This is 2D. Suppose you want to write 3D structure. 3D structure means the better you take a cubical structure. In this metal. So here ligands are approaching x-axis and y-axis. So z-axis is absent. So that's why first of all what happens, ligands are coming on the x-axis. So first ground state. So ground state is excited. So this is called as a degenerated. Next, the ligands are coming on the axis. So who are present on the axis? That is what EG. Dx square minus y square dz square. Next, who are present in between the axis? dxy, dyz, dxz. Next, the z orbital means z axis ligands are absent. So the total repulsion is depends on x and y axis only. So that's why it is a further splitting. So xy is going to highest 1. So dx square minus y square. Next, dz square is decreases. Next, here xy is related, so it will go to higher level. So you are getting dxy. Next, remaining 2 dyz, dxz. So this total splitting you called as delta sp. So the square planar splitting energy. So it is what? So the important this value is higher than octahedral. Square planar is higher than octahedral. It is higher than tetrahedral. This one logic is important in your entrance.